For these two problems, we want to write down the 50th term of the sequence, 1, 5, 9, 13, and then for the second one, we want to find the 27th term of the arithmetic progression, 2, 4, 6, 8, and so on. So let's deal with the first one. Well, in order to find the 50th term of the sequence, we need to know what the nth term of the sequence is, so we could find any term. And because this is a sequence going up in 4s each time, it must be an arithmetic sequence, and if it's an arithmetic sequence, we can use the formula un is equal to a plus n minus 1 times d in order to find the nth term. So to use this formula then, we need to define our first two values. Our a value, which is our first term of the sequence, which in this case is 1, and our d value, which is our common difference, and for this sequence we are adding 4 each time, so our d value is either plus 4 or just 4. So we can substitute them into our general formula for the nth term. So un is equal to our a, which is 1, plus n minus 1 times d, which is 4. If we expand that, we have 1 plus 4n minus 4. So tying that up, we can say that un is 4n minus 3. Let's just check this. If we substitute 1 in, we have 4 minus 3, which is 1. If we substitute 2 in, 8 minus 3, which is 5. Substitute 3, 12 minus 3, which is 9, and so on. So we've got the correct nth term. We now want to find the 50th term. So we're going to use when n is equal to 50. That implies our 50th term, u50, is equal to 4 times 50 minus 3. 4 times 50 is 200, minus 3 is 197. So therefore our 50th term is equal to 197. For the next problem, we're going to go with a similar idea. Now this problem uses the phrase arithmetic progression, but again, that's just the same as an arithmetic sequence. Okay, so it's just another way of phrasing that. So we need to go with the same process, find the nth term, use that to find the 27th term. So looking at our progression then, we have our a value, which is our first term, which is 2. And then we need our common difference, which in this case we are adding 2 each time. So d is also equal to 2 or plus 2 there. So if we substitute them into our nth term, we have 2 plus n minus 1 times 2. If we expand that, we have 2 plus 2n minus 2, which is really nice because our nth term just becomes 2n. Let's just check that. When n is 1, we get 2, n is 2, we get 4, n is 3, we get 6, and so on. So it's a nice simple nth term. So we can use that now to find our 27th term, because that just means that we're using n is equal to 27. So u of 27, u27 is 2 times 27, which is equal to 54. So therefore our 27th term is 54.